Gravity. When we drop an object from a height, it falls right down. But why? Why does it not float in the air or go any other direction? Isaac Newton got the same question when he saw an apple fall down from a tree. He investigated and did a number of experiments and discovered that the Earth has a force which pulls all objects towards the center of the Earth. This force is called gravity. He said more, not just for Earth, but for every object that has mass has gravity, including us. We usually call it as weight, but it is not weight, but mass. We use the wrong term in our daily lives. Let's say a person is 50 kg. That is his mass, not his weight. The mass of any object does not change when it is on Earth, on the Moon, or anywhere in space. The units to measure mass is kg. Then what is weight? It is actually the heaviness of something. Is it different to mass? Yes, it is. Weight is another word for the force of gravity. Weight is directly proportional to mass. That means if an object has more mass, it has more weight, and if an object has less mass, it has less weight. But they are not equal. Do you want to find out what your actual weight is? Then multiply your mass with the Earth's strength of gravity. The Earth has a gravitational strength of 9.8 newtons and is measured in units kg per newton. For example, if a person has a mass of 50 kg, his weight on Earth is 50 kg times 9.8 newtons, which is 490 newtons per kg. This is your weight only on Earth. If you go to the Moon or any other planet, it changes, as the strength of gravity is different on different planets. The Moon's strength of gravity is just 1.62 newtons. Jupiter's strength of gravity is 24.75 newtons. Let's do some experiments. Let's drop a feather and a bowling ball from the same height. We see the bowling ball reaches to the ground first, and later the feather. Why? That is because on Earth we have an atmosphere and air flows. The Earth uses its strength to pull the object down while the air supplies its strength to push the object back up. This causes the feather to fall a bit slower than the bowling ball. The air does not have enough strength to push the bowling ball back up. But if we try the same experiment on the Moon, both will reach the ground at the same time. This is because the Moon has no air to push them up. This time, let's throw an object sideways. Here there are a number of forces applied on the object. One is the Earth's strength of gravity, two is the force applied by the air, and three is the force applied by you. As the Earth's strength of gravity is stronger, we can see it travels a distance and falls down an arc shape instead of moving straight down. This is due to the force applied by you and the gravitational force. If we throw an object very hard, it falls almost in a complete elliptical shape. When the object is thrown really hard, it takes quite a big elliptical turn. If it is thrown hard enough, its path may take a trip around the Earth. What if we apply more force than that? The object can actually escape from the Earth's strength of gravity and can go out of the Earth and into space. This speed or velocity is called the escape velocity. It is measured in units, meters per second. On the surface of the Earth, the escape velocity is about 11.2 kilometers per second, which is approximately 33 times the speed of sound and several times the muzzle velocity of a rifle bullet, which is up to 1.7 kilometers per second. However, as we move up, gravitational force decreases, which means we can escape with a little lower velocity. That's how, when meteors come toward the Earth in an angle with more than escape velocity, it gets into the Earth's orbit. It never reaches the ground. The International Space Station is in the thermosphere layer of our atmosphere at an altitude of 370 to 460 kilometers, where gravitational force is almost the same as on the Earth's surface. But it is not falling down onto the Earth just because it is moving at a velocity of 7.6 to 7.7 kilometers per second, which is less than the escape velocity of Earth. So it continuously revolves around the Earth in an orbit, escaping Earth's gravitational force. If its velocity is more than the escape velocity, for example 11.2 kilometers per second, it cannot orbit around the Earth but will go into space. The space station orbits Earth and sees a sunrise once every 92 minutes. gravity based on density. We have learned that every planet has gravitational strength and we have to move at its escape velocity to escape from the planet's gravity to go out into space. Each planet has different gravitational strength and different escape velocity. But why is it different to different planets? What makes a planet have more gravity or less gravity? Let's observe and compare each planet's mass. The Earth's gravity is 9.8 newtons per kg. If you see Mercury and Venus, they have less gravity as their mass is less than the Earth's. So planets that have more mass will have more gravity. Now, let's see Uranus's gravity, which is just 8.69 newtons per kg. It has much more mass and it is larger in size to Earth. However, Uranus's gravitational strength is less compared to the Earth. So, it is not just based on mass or size, but also gravity is based on density. This means the mass spread across volume. As all the planets are almost in a spherical shape, we can easily find the volume of each planet if we know the radius. The density is the mass divided by the volume. It is measured in grams per cubic centimeter. That means a planet, in fact any object that occupies more volume has more gravity, whereas the same mass occupies more volume has less gravity. Escape velocity is high if the planet has more gravity and vice versa. Thank you for watching.